Okay, let's see if this works. Okay, so this first, I'm taking this one, and this one I'm going to talk about the fire, and talk about how the different attributes of fire, and then talk about coastal Douglas fir and how it's used in timber-built homes and why, and then say the idea behind our experiment, why we used a smaller block, where we got our information from, where we got our charring rate, for how long that works, how long it's feasible for. So this is your part, CJ, the experiment procedure. And so when this slide comes up, that's you. And then you're gonna look over this slide. You're gonna point out our first block is a control block. It's gonna be 3.5 by 3.5 by a height of 6. That one is not going to be charred or burned, touched with fire. It's just going to be a block of coastal Douglas fir. That block is going to be put into the concrete cylinder machine, and the load head is going to come down on top of it so that it's resting on it. And then we're going to put the LVDT displacement transmitter on top of it on the load head. And this is going to be able to tell us the displacement of each block without having effects from the wood breaking or anything. So if we put it on the load head, we'll still get an accurate displacement. And so we're going to get our raw number, our control of how much compressive strength can a normal block withstand. And then or what is our F max? What is our force max that we can apply to this block before failure? And then our second block is going to be burned for 20 minutes under the ASTME 119 guidelines. You don't have to say that. You can just say it's going to be burned ahead of time for 20 minutes. Then it's going to be put into the concrete cylinder and going to be tested the same exact way as our control. And then we're going to have our third block, and that's going to be done until 40 minutes. And then the whole thing is repeated again. And so then we're going to measure the F max, the force that can be applied before failure of each block. So that's the experiment procedure. You can show this next slide, say this was our concrete, but this is essentially the setup. Instead of the metal rings, instead of the steel rings, you can just put the block straight into this, the load, and be compressed straight on top of it because it'll distribute the load just fine. And then just so people get an idea of where we're putting it, and then you're going to show this video, and you're going to say, this is what happens, this is a failure, when we have too big of a block, too tall of a block. It's going to undergo fiber buckling because we have to start thinking about the height of it. And so this would be what would happen if we had kept it at the 8, and that would be considered too tall to actually understand just compressive strength and not buckling or the height of it. So emphasize that it's fiber buckling if it's too tall. Show the video. And then the last one is a small block. Show the video and say this is going to be more of how our block is going to look and the height of it. And when it's a smaller block, when it's not too tall, it undergoes compression failure. And so highlight that it's compression failure, show the video, say this is what we're doing, this is closer to what it's going to look, this is why we did the 6 inches tall. And show the video, and then that's it. And then the next part is Sam's.